Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like part modeling, surface modeling, sheet metal enclosure design, plastic components design, product design, reverse engineering, simulation, and many more tips and tricks in SolidWorks. Hi, today I am going to explain about contact bracket. So left side you can see the component, the right side the flat pattern. So this is the component I am going to create. In this tutorial I am going to explain how to create base flange, edge flange, and how to mirror the edge flange, and how to change the bend radius of the edge flange, and how to use break corner, and I am going to explain how to use tab feature. So let's start now. So I've taken a new SolidWorks part file, select the top plane, go to sketch, select center rectangle, so this is 50 mm and this is 200 mm. So select this line and make it construction. Now go to sheet metal module, select base flange, select mid plane, and this is 40 mm. See, thickness I am going to take 1 mm and bend radius is 1, so equivalent to thickness, and K factor as 0.45. It should be always less than 0.5. See here. So we have to verify the parameters, radius, thickness, and K factor. I am going to create edge flange. Select this edge and flange position, select material inside and say OK. See here. It is creating a tearing operation. So to avoid such problem, so I am going to create one relief and I am going to modify the dimension. So go to edit sketch, keep it in top view, move little bit inside. So this is their design requirement, and this also inside. So distance between this edge and this line is 30 mm and this is 50, and distance between this edge and this edge is 30. See, and say OK. See here I am going to apply relief. So go to edit feature and select custom relief type. Select off-round. and here I am going to take 2 mm. See, you can see the difference. So it has been created, and here also I am going to take 2 mm. So the height is increased, and say OK. See here, this is how it looks like. So it creates the other side. See, when I click the flat pattern, see, this is how it looks. So this is the relief. Now I am, instead of creating one more flange, I can use mirror command. So I am going to select the mirror command and select the right plane and select this feature and say OK. So these are the 2 flanges. Now I am going to create one more flange at this location. So select the edge flange and select this edge. So here I am going to take 70 mm. See here, I will keep it in right plane. See here, and you can see this material is going to tear at this location. So to avoid such problem, we have to select bend outside. See here, it is starting from here, and say OK. See, now I am going to modify the sketch. This is 120, and see here, we have to move little bit inside. See, this is 32. So in order to make equal distance, one thing we can do is we can draw one center line. See, since it is inclined, it doesn't select properly. See here, creates an issue with this sketch. See here, we'll try this. Select this line and this line and this line and make it symmetric. See here, it is exactly at the center. Or else we can do one thing, we can draw a line from here to here and one more center line from here to here, and select these 2 lines and make it equal. See, when I apply, it will take equal constraint. See, these 2 are equal. So then exactly at the symmetry. So this is other method, or we can draw the center line and we can select these 3 lines to make the symmetry. So say OK. See here, should be having sharp edge. See here in the flat pattern. So whenever we create any flange, make sure that it is cutting the sheet exactly at sharp corners. This is important. So now I am going to apply one more edge flange at this location. See here. So the angle is 110. See here, I'll keep it in right side. See, if I keep 90, since it is inclined, it is moving normal to this, but we need exactly at vertical distance. So we need to calculate, and so there is a 10 degrees difference. So this angle is 110 and it is exactly perpendicular to this edge, and we have to select the material inside. Now I am going to modify the sketch. I'll keep it in isometric for understanding. So select this edge. We have to select always this edge, not the inner edge. Outer edge is important. So this is 30 mm. See here. Now this radius is equivalent to thickness, but here we can see the radius is bigger than thickness, so we have to modify this flange radius. So go to edit feature. So here we have to uncheck use default radius. So here the radius is 10 mm and say OK. See here. So radius has been modified. So in specific condition, whenever we apply a edge flange, so automatically it takes the default value. So we have to uncheck this and modify the radius. Now I am going to add one tab feature. So select this face, go to sketch, draw one rectangle starting from this. So the distance between this edge and this line is 10. This is 10. See here, we have to see the direction. See, when I keep in reverse direction, creates the other side. We have to verify this, and we have to select merge result, otherwise it creates a separate feature. So that is important. See here. So similarly we can mirror the feature, or we can create same edge flange. So instead of mirror, I am going to show you how to create tab feature with the same dimension. So here we need to show this. See here, we have to see the sketch. See here, I am going to use this sketch for second tab. So select this first tab sketch and convert entities. See, it is converted. So the advantage is that instead of mirroring the component, this feature, when we make with sketch, in future modification, see here I am creating the sketch. So whenever we want to modify the other tab, so suppose if you want to modify the tab, so I can remove the convert entity and modify this. Or else the advantage is that if I modify the sketch, suppose this is 15 mm, see here, so it automatically updates the other tab. So that is the advantage. So in mirror component, we cannot modify the tab individually. So this is the best method. So hide the sketch now. Now I am going to create whole features. So I am going to apply unfold, select this face, go to unfold, collect all bends and say OK. So go to simple hole feature and select this face and come out of this feature. Now modify this sketch. See, in sheet metal whenever we are going to change the hole diameter, we have to create a separate feature. So this hole diameter is 10 mm. So I am creating this hole. So now I am going to mirror this hole. So select this circle and select the center line. See here. See here, you can see this hole 1 is mentioned. Suppose if you want to identify the hole diameter in this feature, so what we have to do is we have to select the character map. So it is available in Windows. So you can select this and select this diameter, select and copy this. So in renaming we can use hole hyphen and we can paste it, Control P. So the diameter is copied here, so that is 10 mm. So we can mention like this. So this is the best practice in sheet metal. So now I am going to create one more hole feature. So select the hole command, place it on this face. So this hole diameter is 12 mm and say OK. So here also we can modify like this, Control V and 12 mm. See here. So it's easy to identify in the features 10 mm and 12 mm diameter. This is useful for more complex components. So this is 12. So now I am going to select the center line and this is 120. Select this origin and this and make it horizontal. Select these 3 circles and make it equal. Distance between these two is 30 mm. This is 100 and select these 3 points, make it horizontal. So it is fully constrained now. Select mirror command, select these circles and select this and say OK and come out of this sketch. So these are the 2 different hole features with 2 different diameters. Now we have to fold this. Select the fold command, collect all bends and say OK. See here. Now I am going to apply the fillets. So we should not use this normal fillet in sheet metal. We have to use break corner. And here we have a fillet. So fillet is 5 mm. So wherever we see the sharp edges, so we have to apply the fillets. and say OK. So this is the final component. I am going to show you the flat pattern. So I am going to hide these sketches. See here. This is the flat pattern. So this is a brief about contact bracket in sheet metal module. Thanks for watching. For more videos on SolidWorks, please subscribe to my YouTube channel, Mechanical Tutorial.